Yeah, and that's totally good. I did want to double check our audio, so give me one sec. Here we go. Sir, perfect.
Okay.
Sounds good. Okay, so we got audio coming in.
So
Want to mute that, and I've got our live chat available and updates, so feel free to jump in there. Oh, I got some bugs and got a lot of lava that I need to work out today. So that's the goal. The goal is to fix some bugs, and I thought I would do it on live stream and just hang out if you wanted to hang out. So that's cool. And I need to open up my Asana page with all of my bugs there. So let me go open that up in another tab, open a new tab. All right, there is got a lot of lava. And some of the bugs are just kind of really edge cases and weird stuff that I think will be relatively easy to fix. Let me move this one here, move this one there, move that there. Okay, cool. I'm trying to get my desktop set up and then have live screen capture there. Cool, so we're good. Hey, welcome in. Thanks for joining. So today, fixing bugs in Got a Lot of Lava is the plan, and one of the bugs that looks really easy is Infernal Lava doesn't display when we enter Infernal Lava mode, which is super strange. So I'm gonna go start screen sharing for you. We're gonna go into scripts and scroll down to, where is this being displayed? Let's go into Open External Editor. And I suspect what we're going to find is it's not being displayed. So I'm going to zoom out just a hair so I can see a little bit more, Control minus. Hopefully that's still legible. But yeah, we're just hanging out today and fixing some bugs. That's all there is to it. Alrighty, I need to find in the script where, if I go to Game Manager Defs, there is this thing called Infernal Lava. I need to find out everywhere where Infernal Lava is being used. I'm curious if maybe this space is part of the problem, but we'll just start with going Command C. We'll go to the search bar over here and Command F to search for Infernal Lava. We can see all the places it's being used. So we're here in definitions where it's defined. We can go to the Game Manager Func to see it being used there. We have Stone Pillar Functions, has a state called Infernal Lava, and it uses the same divisor as Nightmare, so nothing changes when we enter the, let's go quickly, spelling, add to workspace settings. Right click, spelling. That's interesting. I should have added it to workplace settings. Okay, we'll ignore it for now. But anyway, Infernal Lava, there it is. That one seems okay. So then on the Game Manager Func, we have if lowest player count does not equal 1. I don't know what this is doing, but let's just try to follow the path of, oh, okay, maybe I see what's happening here. So we're setting the game state based off of some properties inside of the loop, but that doesn't actually update it. Ah, see, this worked before because we were using a Boolean, but I've switched it up to use this game state. The problem is we don't check the game state before resetting it, question mark? No, that can't be the case. Let's think about it. Current state is set to Infernal Lava, and this is when lowest play count does not equal 1. Okay, so just to quickly recap, what is Infernal Lava? Infernal Lava is this idea that once all of the players have died at least one time, the lava just rises until it kills everybody, because you've all died already, so there's no point. Let's reset the game and play again. And so it goes through and it says, okay, we increase the player time and update displayed time, which is probably where we update the play count. And then we set lowest play count to 99. We could set this to 2. It really doesn't matter because it only matters that it does not equal 1. And so then we go through lowest play count. We need to find somebody whose lowest play count is 1. And I think that's the reason we're doing this first, because otherwise it would be 0. And so we go through and we find the count, the number of times that they've played, and we find the minimum by doing math.min, and we go through each player to determine what is the lowest, and if that lowest does not equal 1, then we know everyone's died at least once. So once that's the case, we then set game states to Infernal Lava. Now down here, we're going to use a case to check that we're in the Infernal Lava state. So this is where I'm confused why this isn't working. So let's see. We say let next state equal game state friendly, so we start as a default of friendly. And then we go through each state and we say if we're in friendly, we're going to move up and set the next state to easy so that the next time this loop comes through that it's in easy. And then game states easy comes through. And so we have friendly, easy, medium, hard, nightmare, and then Infernal Lava. Now we break here. we start the move to, so we're going to move to the higher position. We then stone pillar function set random seed, so this resets it just like we do in our nightmare, and then we set the next state to be infernal lava rather than nightmare. Question is, at what point is this switch not covering one of the cases so that next state isn't set to friendly? What is happening? Like, when is this just like a fallback? Let's go check the definitions file real quick. And we can see we got friendly, easy, medium, hard, nightmare, infernal lava. So theoretically, current state will always... Oh, does current state have an option to be undefined? Let's see. Game state. So current state. No, it's definitely going to be defined. So it will choose one of these. Very curious. So if current state does not... Oh, it's for checking if it's not the next state. If current state does not equal next state. Is that what it is? So current state starts as friendly. The next state's already been set. I don't really know. A lot of logic I wrote a long time ago, by a long time ago, I mean a week ago. And my brain's like, what did I do? It makes sense, it works, but not entirely sure. If game manager does not equal current state, then we play the stuck pop-up. So is the problem that the problem is that the state never changed. So it does run on infernal lava. It is increasing the lava height. It is changing the seed. What it's not doing is showing the pop-up because we set the state before coming here. So next state and infernal lava do not equal the same thing. Got it. Makes sense. Okay, that totally makes sense. So then what we need to say is or. So it's like, okay, it's either they don't equal the same state or game manager data dot current state triple equals game states dot infernal lava. Okay, now that should actually display the thing, and that is one bug checked off the to-do list. Hi, Jeff. Thanks for joining. Let's go and mark that off my to-do list. So infernal lava doesn't display is now fixed. It's just really hard to get to infernal lava, so I just wasn't sure if it was actually happening. So that's great news. Next up, we have current time for tracking most recent hit is preventing legit hits. I want to find something easy to work on. Snowballs should only work on players when held. So some of this snowball stuff should be easy. Let's start there. Snowballs should only work on players when held. This is a part of a larger set of things that I want to do with snowballs. So there's two bits here. It says snowballs, currently, they also work on stone, and that's the problem when held. And they also need to be force released when they do hit a player. So let's get over to our snowball scripts. We're done with these two. So we're going to go down to snowball entity. And in snowball entity, we are saying we don't have a tracking for is held. So we need to start by doing another Boolean to check if is held. So we're going to Control-C, Control-V, and add is held to this, which will start as false. And then when grab start, we'll set this dot is held to equal true. And then Alt arrow up, Control-C, and then we'll put that on grab end as well. And we'll move that down a little bit. And so when grab end, we set is held to false. So now we have a way to track if the player has thrown the ball or not, or the snowball or not. And now down here when we do player collision, we will allow a player collision even if held, but at the very end of this script, so we said if current holder triple equals undefined, here we have current holder does not equal the same player, so we're hitting another player. And in this, if we've hit another player, at the very end, we want to run quick if statement and say if parentheses is held. So if it is held, we then want to say is held equals false. So we're going to force release it, and then we say this dot entity dot as parentheses grabbable entity dot, or then after that dot force release parentheses, and semicolon at the end because I like semicolons. Control save. Okay, so now if it's held, it force releases, which marks off when snowball hits players when held, force release, done. And then snowball should only work on players when held. So in entity collision, we do not want to allow entity collisions unless they are, oh, did I write this down? Okay, yeah, it is. That was the one that I thought was complicated, but it's not actually that complicated. Okay, so if is held, so if is not held, so exclamation point, if not held, then we allow all the stuff in entity collision to occur. So that should fix a couple bugs there. So the bug number one is that we didn't want people who were walking around on mobile to accidentally bump into a pillar and it uses up their snowball. And bug number two is that when they were bumping into it, it was setting current time to be date.now. And that was a problem because it meant that if they were using it immediately after hitting something, it was causing it to not work, which we still have happening up here on player collision. And so our current time stuff needs to only happen if not held. So when we say this dot last hit time equals current time, we only want to update that if it's not held. And here we're setting force hold. So I think what we can do is say if, yeah, here's what we do. We say, okay, current time minus last time is greater than this. And so we're going to add ampersand. And then we'll actually put this at the beginning because I don't want to do the math unless we have to. So we'll say, and then like the order of this if statement. So this first thing will cancel the rest of the if statement from running if this is true or false, excuse me. And so what we want to say is if is held and the current time is greater than 1,000, then we do all this. Else if the current holder does not equal player. And so if is held, and then this if should be checking if it's not held. So we'd say this dot held is held, and then we say not held. So now we're saying, okay, if it is held and the current time is greater than 1,000, we can update the current time. Interesting though is that we're not updating the current time all the time. I'm wondering about that. I almost feel like we don't need to update the current time in player collision. This was to prevent the collision from happening twice, but it's not really being used correctly here. Think. Let's redo some of the logic in here to be more what we want. Okay, so we're going to check if current holder does not equal player so we don't collide with ourself, the holder. Oh, I see. We actually had this if statement wrapping around all of this. Okay, that makes sense. So we're updating the current time, and then last hit time equals current time, but we actually don't want to update last hit time if parentheses is held. So if is held, and we want to say not held, then we will update the last hit time. Otherwise, we won't update the last hit time. And then if not held, update last hit time. And then if it's not held, we can then attach it to the player using, or force hold it using this right here. The only problem is that else if I guess we'll just keep that the same. Really, we're just trying to fix the fact that the current time was getting updated too frequently. This does mean that multiple collisions could happen when it's held and you slam the snowball into a player, which seems problematic. So when we hit the player, we want to do right here, oh we did, we set it to false. Okay, so that's going to stop it from running a second time because is held will be set to false. It might run twice though. Maybe what we need to do is do this, Control C, update last hit time when we're updating the held time. Shift Alt F, there we go, Control Save. So is held is set to false, last hit time is set to current time because we know up here if it was not held, we updated it, and up here if it is held, we weren't updating it, so we do update it. Cool. It's a lot of dumbness, but there we go. Hey, welcome in if you just joined us. We are just fixing some bugs here on our snowballs So far, we fixed 4 bugs. That's pretty good. I had my goal was to fix 1 to 6 bugs, and we're only like 12 minutes in. So doing pretty good. I guess I had some bonus things I'd like to work on, but we'll see if we get time. I do have a class I have to teach in 1.5 hours, so I gotta get ready for that probably in about an hour. Okay, bugs. Not showing winners shows empty pop-up when 2 players and other enter as game is ending. And then static pillars shouldn't do anything, not even connect event. Oh, okay. So, and then there was another thing that needs to be fixed. I wouldn't call it a bug, but I'm going to put it at the top of the list. I'm going to move showing winners to the bottom because I need a second person to test that. My hope was to read through the script and figure out what the logical error was that would cause that problem, that bug. But we'll see what happens. Okay. Static pillars shouldn't do anything, not even connect events. Okay, we're done with the snowball entity, so we're going to go to the stone pillar entity. And in here in stone pillar entity, we have this boolean for is static. And in pre-start, we're connecting an event, but we only need to connect that event if not, so exclamation point, and then props dot is static. So if not static, we will connect events. Otherwise, there's no need to connect events because it's static, it doesn't do anything. And then in start, we're doing a bunch of stuff. We have a distance adjustment, and we have a tenting. The tenting can stay, but this distance adjustment needs to be moved into our it's not static. And that distance adjustment is used in our motion over time, which is called here, right? Where is this distance adjustment being used? Hello? Oh, is it over to the right? There it is. Okay, cool. So yeah, that'll do, that'll do. Control save. There's some other cool ideas I have that I want to implement for this stone pillar, but that's not a super high priority right now. But yeah, let's mark that as done. There's a 5th one done, wow. And then there's just one last bug, and I've finished all the bugs. That's bonkers. But before we fix that bug, I wanted to go to an easy thing. I like doing all the easy things first. It feels like snappy and exciting. So let's go to, what was it? Player hit length needs to be 3 times longer. That must be on the snowball. Okay, so back on the snowball entity, we have the hit length being 1500 milliseconds, which is 1.5 seconds. I want to change this to 3.5 seconds. I feel like that will be enough length that it feels more painful, because right now it's such a short length, 1.5 seconds. I thought 1.5 seconds was going to feel longer because of the intensity of the lava environment, but it just didn't. So I'm hoping 3.5 seconds is enough to like make you realize, dang it, I was hit, that sucks, because it just wasn't before. So here we have our player collision, and we are using the frozen by, and we had freeze duration milliseconds being used for haptics. So for 3.5 seconds, you're going to feel medium haptics. It's a pretty long time. I'm not sure I love that, but we're going to stick with it for now. And then we have fixing the locomotion, setting it back to normal after the duration milliseconds. I think all of this is good. The problem was on entity collision, we were multiplying it by 3 because it just wasn't long enough, and that made it 4.5 seconds. Right? No, it was 1.5 times, yeah, 4.5 seconds. I really wanted to match that. Let's actually change it from 3,500 to 4,500, because I think that might be enough time for both. And then we go down here, and there is this part of me that feels like the freezing of the pillars. So when you throw a snowball at the pillar, it freezes it in place. I almost feel like that's not long enough. So I was thinking about even multiplying this by 2. But that gives you 9 seconds, which on the very end game would be huge. So I think we have to leave it at 4.5 seconds. It's got to be really highly skill-based. So that is that. And then that sends the local event freeze to the pillar, which was that event we had just disconnected from over here for the not is static. Okay, cool, cool, cool. Very good. That is fixed or finished or updated, whatever you want to call that. So not showing winner properly. This is scary for me because I don't know what's causing it. I don't have any suspicions. Like everything else, knew what I was doing. This one, nervous. Not showing winner shows empty pop-up when 2 players and other enter as game is ending. So let's figure this out. This is going to be on the game manager function. And game manager function has this game state loop, right? Let's see, I don't know if I care about that. What we care about is this end. Let's work from the back. That's always the best way to discover a bug, is to work at the very end. And so the end is right here where it's displaying the player who won, their best time, and how long they lasted. Okay, so this isn't actually it. This is similar, but this is not it. We want to find all the play pop-up function instances. Command, can I fix this already? Spelling. Why is that create custom dictionary? Normally there's like add to user settings. I must have messed something up somehow. But anyway, because I added that to user settings last time I was here. I don't know why that's there. I want to search for pop-up. Command F, search for pop-up, and func. There we go. Now we're going to go look through all the pop-up func instances. So here we have, for each player, play stuck pop-up, which has the display me. So it's best time name. So this is the player who won. Okay, we did find it now. We can close out of this. Let's put a red dot here because this is what we're trying to fix. Who won and their best time. So I saw this coming in empty, which doesn't make sense, does it? Oh, it does. Look at, we said best time name equals, oh boy, never mind. It's a race condition. That makes sense. Maybe it's easier than I thought. Best time is 0, best time name is empty, so that's why we're seeing it reply empty, because the maps were already reset. So right here we're going into the best time map. Somewhere the best time map is being cleared out. So there's nobody left in the best time map. So let's find wherever this is happening. Command F to find best time map. We can now see all the instances of it. There's 5 of it. I think we're at the first one here. We'll go to the second one, which is down here when we're using it to get the player. I did want to have a special pop-up here. Let's put down a comment for this. Special pop-up for the player who won. And that's a good idea. We'll put a red dot next to that. Should be pretty easy, like an if statement to just check if player equals player and then do something slightly different. Now, going to the next one here. We have best time map on start game. Okay, so the player enters, but the pop-up was being called with a delay, perhaps? Oh, player data dot for each place. Ooh, is this it? Best time map dot get player. Your number would equal 0 because it's being called 1.5 seconds late. Oh, this whole thing is being called 1.5 seconds late. Ay, ay, ay. Oh boy. Okay, it might be as simple as just removing this all from the async, or doing the calculation of the pop-up before the async and just delaying the showing of the pop-up. Like, that makes a lot more sense. Just delay the showing of the pop-up. Ay, ay, ay. It's really simple. Okay, good. So we can fix this. Sorry. It's an emotional experience fixing bugs. I'm not even kidding. It really is. Okay, so what we need to know is the pop-up to show, and we need to show it with the delay. One of the questions is, I've been giving out a bunch of assets. You might have seen some of them on the main channel. And I'm not sure if I gave out the pop-up function asset. I'm going to do a check. And TypeScript utilities, there is utility. It's not in here. Okay, good. I'm not really done with it. It's one of those things that's still being like work in progress. I might consider uploading it in the future when I'm done with it, but I'm adding another feature right now. So if we go to our pop-up function, this is kind of a utility I've been working on, but it's not really meant to be a utility, but I end up using it like one anyway because I copy-paste it to all my worlds. It was just kind of a means to an ends when I first built it because it plays a pop-up, and then I was like, oh, but I need to like not override a pop-up, so I created a stuck pop-up, and now I need to play a pop-up with a delay. So what we're going to do is quickly write this in, which is going to be called function play pop-up after delay. So play pop-up after delay is going to take all the same properties. We're going to copy paste the play pop-up properties, Command C, Command V, with one additional property, which is the delay in milliseconds, which will be a number, and then curly braces. And all this is going to do is call, and we've got a component utility now, dot component dot async dot set timeout, parentheses, parentheses, and then arrow function, curly braces, comma, and then pass in the delay in milliseconds, and then semicolon. And then inside the curly braces is where we call the function play popup, and then pass in the same parameters. And I think we can just control V that in. Yep. And then semicolon, and then delete all the stuff we don't need, which is this, which is this, which is this, and one more right here. Okay, so we pass the player, the message, the duration, and the is cross screen boolean. Shift Alt F to prettify it. Prettify, that's a new word, just making it up on the fly. All right, so now we need to export this function. Control C, put it up here. Control V, comma, Control save. All right, so we got a new option in our play popup function, which will allow us to take this entire thing and move it up outside of this async. And then this is definitely not as optimized. And there are definitely other ways of doing this that could be more optimized, but I don't think we're in an optimization crunch for this, so I'm not worried. And so instead of playing stuck pop-up, ooh, these were stuck pop-ups. When you realize they were stuck pop-ups, we need to go to pop-up func, and then call the Control C, same function, slightly different, Control C, Control V, and we're going to call this play override pop-up after delay. Now we don't have an override pop-up, so I'm going to be making this up on the fly, but that's okay, because I think this is a good one to add, because I don't think stuck pop-up overrides the previous pop-up. Maybe it does it? Player unstuck time map dot set to play pop-up. It plays the pop-up no matter what, so it's going to replace it. So a stuck pop-up does replace the okay. In that case, we're just going to rename this to play stuck pop-up after delay. I should document this better, so just for the sake of document right now when I know what it does, /** enter, and then we're going to say plays a pop-up for a player that cannot be overridden by anything other than another stuck pop-up. Okay. Overridden. Why is over? It's just one R, isn't it? Why is that? Spelling suggestions. Double R? Overridden. Is that not a word? Plays a pop-up for a player that cannot be... what's the word? I'm going to use overridden. If it's not a word, don't tell me about it. By anything other than another stuck pop-up. Okay, so plays a pop-up for a player that cannot be overridden by anything other than another stuck pop-up. So the question is, if you call play pop-up after delay, and it plays the pop-up, it checks the time map, whereas the stuck pop-up plays the pop-up and clears out the unstuck time map. It sets unstuck time map to 0 and changes the duration, and it seems to work. Let me I don't actually remember how this works. So we said player unstuck time map equals player unstuck time map dot get player. And then we say if, okay, we check the component, verify that, and then we say player unstuck time map triple equals undefined, or player unstuck time map is less than date.now. By setting the time to 0, it's less than date.now, which allows it to be updated so that it can't be overridden. And then unstuck time map dot set is happening after the playing of the pop-up, which is set to that duration, which prevents this from playing in the future. Got it. Okay. This is hacky. I feel like this is hacky, but it works. So, okay. And then play stuck pop-up after delay does the same thing, except for instead of calling play pop-up, it calls stuck pop-up. And so there we go. That is done. Control save. We have 2 new functions in there. Beautiful. And now instead of calling, I got lost in here. Where are we? This has got to be it. So instead of calling stuck popup, we're calling play stuck popup after delay. There we go. And we need to add the delay in, which was 1500 milliseconds. So we'll just type comma 1500. I don't know why it's a magic number. Maybe I'll fix that later. But there we go. Okay. So now we're going through the best time map, and we do need to know the winning player. So we say let winner equal we'll say it's of type player or undefined, okay? And then when we go through the best time map, we are saying if time is greater than best time equals that time, and then we get the name of the player. We also want to get the name of the winner, so we say winner. Ooh, but this doesn't account for multiple players, which is what this does. So it actually needs to be a player array. So let's delete this undefined, and then change this to be a player array, which equals an empty array, and then we'll add players to it as we go through each player. So we say winners dot push parentheses player, and then there we go, semicolon, Control C, and paste that down here. Okay, so that's how we're tracking multiple winners. Control save. So now that we've got a list of the winners, and we don't need to make this a let, this can be a constant now, and then we can now go down to for each and add this if statement that checks if you are a winner. So if parentheses winners dot includes parentheses player. So we're checking if the winners includes the player, and if winners includes player, curly braces, then we want to do something slightly different. So then we'll do else, curly braces, alt up, backspace, backspace, and we want to do Control C, excuse me, Control V, and then what we were doing in display me was taking best time name, so we have the name of the winners, so you all won. Let's see. I really want this to be very bold for them. So let's try doing, and I believe you can do this. We can test it in a second. It'll say B, that should make it bold, and then /B should make it unbold. And then inside of here we can type you won, exclamation point. And then we'll do a break after this title. In fact, we'll do 2 breaks to really make this emphasis on it. And then on the next line, we're not going to use display me. We're going to say winners, and then inside of that we want to take the list of winners, which we have as the best time name. And so best time name is the first player name, then comma, then the second player name, then comma, and then if there's a third tie, it continues on there. That's kind of a ridiculous amount of things, but sorry, my throat's gotten a little. Best time names, and then we want to add winners, colon, and so at the end of that it'll say winners, and then it'll have the names of those winners, and then after that we want to display the time. And so right here we're getting the time of this player, and then so we'd say plus, and then maybe time, colon, so maybe we do a space, space. Now we should do this on another line. Break it down to another line. So we got a list of the winners, and then right below that it says time, and then space plus, and then we get the time for the player, but we already have the time for the player, so we don't really need that. All we need to do is just get the best time and put that in, and there we go. Okay, so now we say, you won. Here's the list of winners. Here's your time. And then play that. Cool. We got a special pop-up for winners now. Because if you were a winner previously, you received your time twice. Because this shows their time, the winner time, and then your time. And it's just like, wait, what? Okay, so that'll do. Let's see, checking my to-do list. Let's see. Got a lot of lava. Here it is. Not showing winners empty pop-up. We fixed that by not using a delay. So some of the things I wanted to work on that I feel like are really important is making the game more fun. I really don't love the funness. Also, I should mention that on the main channel later today, which is after all my official work is done, I think that's it's in a few hours, like 3 or 4 hours. I'll be doing a tutorial on custom UI, so I'm avoiding doing those tasks, but I wanted to add some more fun to this because I felt like fun is missing, and there's some ideas on how to make it fun, and I'm just pulling those ideas over for now. And I think the main idea that's actually going to work to make it fun is giving users more influence over the game. Let's go test it and talk about it. So I've got the game here. The code should be all compiled. Looks good, no errors. Go ahead and pull that down a little bit. Hit play. Jump into preview mode. And there we are. Jump in. Okay. So this is a cool concept. It is fun. Mathematically, it is interesting. There is a lot to enjoy about this. Don't get me wrong. But from a fun perspective, it just wasn't fun. Like, I've played this game a lot, and it didn't have me coming back for more. Like, I've played it every day because I enjoy it, but it wasn't like I had I've got a snowball. Okay, so this is actually kind of cool. If I walk into this, it doesn't do anything. Jump over here, and then if I want to jump onto, let's say here, and then drop it, X, is it? Oh, it's throw. There we go. Now this is locked for 4.5 seconds, and then I should have saved it until right now. The point is, I have no control over these blocks. They're just kind of doing their own thing. And so I was thinking, how can I add control? In 2 seconds, it's going to get really hard. Here we go. Nightmare. Oh no, dead. You won. Winners, video, time 61. That looked great. That was a nice pop-up. So the thought was, in Fall Guys, one of my favorite elements of Fall Guys, which is all I knew Fall Guys for, was the hexagon, like, dropping game mechanic, where after 3 hits it falls out below you. And I can see some inspiration, but that wasn't really where this came from. We built this way before I ever even knew what Fall Guys was. Because this game originated from 3.5 years ago. I built the first version with Mark Julian. And we were just doing it because we loved Pearl and Noise. Like, Pearl and Noise was fun. He found this cool art style that worked out pretty well. And but what we could do that I think is what makes the Fall Guys hexagon dropping out below you mechanic so fun is the fact that you as a user walking around have a lot of control over the world. Drop it, drop it, drop it, drop it. There we go. Okay, I'm locked in place for just a second. 5 seconds until the next one. There's no way to get over there. I was like, can I get to the nightmare? Oh, so close. Okay. Cool, that's fun. That is a lot of fun. But it could be more fun. And I think that's the point of this idea. So the idea is that when a player is standing on a block, I want it to sink. And if a block is sinking when a player is on it, I think that's going to have the biggest impact for the user experience and what's actually going to make this game fun. Because right now, it really is lacking in fun. As much fun as I just had there, the fun is really just, it's missing. And you can imagine if you have multiple players in there and their blocks are falling, you can utilize that. And if you've ever played Fall Guys or any of the other similar hexagon fall type games, you get to try and kill other players. And it makes strategy a thing. And like, it just changes the way the game is played. So that is my next thing to add. Welcome in. I see we got a few people joining us. There's the camera. Hi! Thanks for joining. So how to do that is actually very difficult. And I'm trying to figure out what we're going to do to make that actually happen. my thought process is to have every single tile track if a player is on top of it. That's not the easiest thing in the world to do. I don't think it's efficient either because there's hundreds of these, but there's only like, you know, a dozen players. So it makes a lot more sense for the players to be able to tell the tiles where they are. So how in the world can we do that? There's also, like, we could do player collision events. So when a player collides with an object, which I think is happening when they step onto it. So that could tell us when a player is on it. I'm not entirely sure. I love the idea of like players jumping up and down, causing it to sync. So if you're like trying to get it to sync faster, you could jump up and down. I'm also concerned about the gameplay ability for, this is a 24 player world right now. We've really seen a maximum, I think, of like 12 players in here at any given time playing. And with the current method, it doesn't matter how many players are in there because the syncing isn't controlled by the players. But if you have 24 players, the syncing is going to happen a lot faster. And so there's definitely a question of how does the difficulty level affect the syncing? And that's kind of an interesting peculiarity. So got to think about how does it sync based on the number of players? How do we determine the number of players above each one of these? I kind of want to do the easiest thing. There's this concept that here we go too. But there's this concept of don't try to optimize it unless you have to. And I'm not sure if I need to optimize it. So if I take the player's position, which I think I'm already doing, and I store it inside the player data, then for every single player, we rip through and check the position and the distance. That might be fast enough. Like that might actually be fast enough to determine. We could also remove the players from the array once we've determined that they're on top of our tile so that it progressively gets smaller. So think of, we think about this as like exponential growth. So if you have to run, we have, I think 150, maybe 200, let's call it 200 tiles. So if you have 200 tiles, which just for a reminder, there they are. So if you have these 200 tiles and then you have 24 players, you have to then for every tile run that 24 times. But if we take that and after a tile has discovered a player, remove the player from the list, we then can progress pretty fast. And then rather than updating this like 10 times a second or 70 times per second would be like the fastest you could do, we do this twice per second. We're now not doing as many operations. So as much as I was worried about doing it this way, this is definitely the easiest way to do it. So let's go ahead and do it. The first thing we want to do first, though, is make it so that the pillars are not, let's go into the stone pillar script. Where is that? Stone pillar script. And I want to write down this thought on my notes over here so that I don't forget how I want to implement this. So the idea is track position of player, remove from list once their tile is discovered. Okay, I wrote down the note. Okay, we got the stone pillar function, which doesn't do much. That's okay. We're going to go to game manager. No. We're going to go to the stone pillar entity, which is right here. All right, so stone pillar entity is how we're going to move up and down. But the thing is, we don't want to move every second. So previously, we were doing move to next position, and we were doing that at update speed, which was twice per second, 500 milliseconds. And move to next position was incrementing I, which allowed us to see the subtle changes of Perlin noise. Instead, what we're going to do, though, is use Perlin noise to determine the starting position. Oh, I need to write down a note about number of players decreases the effect of stepping on a stone. So ideally, if you're playing as one player, you have a lot more effect on the decreasing. And then as you have more players enter the world, it's divided across the number of players. At least that's the idea. So then, lots of thoughts, just trying to make sure I don't lose them. But now we go to, let's see, we have this I value, which we are going to delete. Ain't no way. Are we really deleting I? I think we're just not going to increment it. Previous Y scale. I think we need I, but we can't keep incrementing it is the idea. So Shift Alt F, because I is set to stone pillar data dot random seed. But what if we deleted I? If we delete I think we're okay. Let's check. Backspace. Go to here where we're using I. We can just delete this. We can then delete the purple parentheses. Control save. No errors. Okay, cool. So we don't need I anymore. We're using this offset to create our kind of starting position. We then need to know how much down we have moved. And we also need to know when the random seed changes. And I think that's the most important piece, is we need to know when the random seed changes. Because we only need to move when a player... I've got another idea I need to write down. I believe part of the fun of this game is the almost organic motion. So I want to add organic bubbly motion to static positions. To do that, I'm unfortunately going to need to re-keep I back in here. So let's quickly add I back in. We're not going to use it the same way we did before. I am going to delete the use of I right here. But what we do need to do is track I. We also need to track the current seed. So where we were using I before, we're going to actually create a new value called current seed, which is going to equal 0 by default. And then we're going to say inside of our move loop, the current seed needs to be updated here. So we say current seed equals, and then stone pillar data dot random seed. And then what we need to do is check this before we set it. So say if parentheses current seed triple equals random seed, or does not equal, so exclamation point equals equals, exclamation point equals equals. Boy, am I having trouble with that one. And then stone pillar data dot random seed. Because in addition to updating the current seed when random seed comes through, we also want to take, let's see. In addition to updating the current seed when random seed comes through, we also want to give my brain a second to catch up and breathe, and breathe again. Sorry, really just like freezing for a second. Okay. Current seed equals random seed. When that changes, we need to reset the value that is how far down we have fallen. And so we need another value called down by. And this will be in meters. So down by equals 0 by default. And then when we update the seed, we need to update our down by. So we say down by equals 0. So that resets it whenever the seed gets reset. And so every 15 seconds, we update the random seed by changing the difficulty. So we go from easy to medium to hard and so on. And that will affect that and decrease the down by. So it basically resets the level every 15 seconds. So you get a chance to survive again. Okay, so now I offset is calculated using random seed. That's the starting point. We then need to take our, and I think we can remove these again. And so because this is a bunch of multiplication, but I want it to be visible to understand what it's doing. So multiply by 0.02 is just some number that we found that worked really well. Now we're going to take that number and multiply it again. No, we're going to subtract, because I offset is only, no, we're going to use this somewhere else. Never mind. Okay, delete the golden parentheses. They're not needed either. Okay, so next Y scale. Here's where we're calculating the Y scale. And so we're using a bunch of Perlin noise stuff, and we had this I offset, which was calculated there, which is what we're adding to. So that's what our random seed is. And then We're also using the position, our X and Z position, to calculate where we're at. And these are really only calculated once. Yeah, these are really only being calculated once per. So we could create a start Y scale and utilize that so that we're not using this math over and over and over again, since we're not changing it frequently. So let's go into our here and create a new start Y scale, and that will start as 0. Our start, yeah, it is a scale, it's not a position. Interesting. Interesting indeed. We'll have to address that. But anyway, we want to change our starting Y scale here. So start Y scale is going to be calculated using this, which means I offset will also be calculated here. And then we're going to cut and paste this, Control X, and paste that up to start Y scale equals Control V. There we go. So now that we have set our starting Y scale, we can utilize that over and over again without having to recalculate it. And now letting next Y scale is going to be taking our start Y scale and subtracting our down by. And now we cannot let this down by, sorry, it's start Y scale, there it goes. And then this down by cannot get below 0, so we're going to say parentheses. In fact, we seem to say that it's a negative 3.9. Math.max. This is where the math.max is coming into play. We should really calculate this. Let's Control C this down here and just clean it up a little bit. And then we're going to call this next Y scale. Oops, Control Z. Control C, Control V. And we don't need everything in the purple parentheses, so we'll follow all the way over to purple parentheses, backspace. And I'm not entirely sure why negative 3.9 is the number we're using, but we are, so we're going to continue using that. And so we're going to take our start Y scale, subtract our down by, and we will not let it go below negative 3.9. And I know that this number, negative 3.9, creates the position that is just below lava at its lowest. So that's what that is. We can now delete this one. And then this is actually not a this is a let next Y scale equal this. And then it says calculate the difference. So if the difference between the next Y scale and the previous Y scale is too high, we then change the next Y scale so that way it moves at a slower speed and doesn't kill people as fast. Gives you a chance to get off the tile, that is. And then we scale to this dot start scale, add the next Y scale. Ah, that's because we have a start scale. That's why it can be negative 3.9, because we're adding to the starting scale, which I believe is 4. And then what we're doing here, after adding that, is scaling 2 over time. And the thing I wanted to do was utilize this I and throw it into a like a sine wave. And by using a sine wave, we can create this sort of natural up and down motion. And so I thought we could do that pretty easily by setting I to be equal by default to math.random multiplied by 2 pi, which is 2 times math.pi. And 2 pi is 1 radian, right? And that is the equivalent of a full circle. And so multiplying by math.random creates a specific point around that circle. Using that in sine waves gives us an up and down motion, meaning it chooses some place along one full circle or one full element of the sine wave. And then it chooses one of those positions, which we can utilize as a starting point. And then by incrementing I upwards, and rather than doing it I plus plus, we can do it at a smaller value and say I plus equals, let's say 0.1 for now. We can then utilize that value in a sine wave. And a sine wave is going to return a value between -1 and +1, if I'm not mistaken. And so we can then say our we can just modify the value of the previous y scale equals next y scale. Next y scale, we still don't want it to be too crazy. So right here when we're calculating next y scale, we're going to add to this with our sign. And so we're going to say plus math.sign parentheses I. I'm going to sneeze, I'm sorry. Excuse me. Oh my goodness. Let me grab a quick sip of water. Okay, so we're going to get the sign of this number. It is an angle measured in radians, so we did good on that front. And then this is unhappy because it's this dot I. This dot I. Okay, and then my problem with this dot I is that it's too large of a number, and I want this to be a small, subtle difference. So we're going to multiply it by 0.1 so that the change is very subtle. And then this is going to be, I think, a little too fast. I think I want to change this from 0.1 to something else, but we'll start there just to see what it looks like. But theoretically, what we've now got is an island of things. Oh, we haven't used the down by. Down by is set to 0. Next y scale needs to be, so we're doing this whole math. Ugh. Let's create a const called ideal y scale. We'll call this, maybe call this calc y scale. So this is the calculation for the y scale, and then we'll use math.max as its own separate thing to keep this clean. And then that goes to right there, Control X, Control V, and then we can put calc y scale here. There we go. That reads a lot easier. Why is it unhappy? Math.max calc y scale equals a number. Let, expected a parenthesis. I see the parenthesis. You trip it? Oh, it's parenthesis supposed to be out here. Yeah, something weird happened there. What is unhappy? Not sure what happened. Oh, I must have cut the wrong parenthesis somehow. It's okay though, everything's fine. So we have the calculated y scale is this dot start scale minus down by. Oh, we're using down by. Okay, cool. And then we add to it with the sign, and that's fine. Anyway, this is easier to read, and that was the point of separating it, is we can now read that a lot easier. Okay, so now that we've utilized all of our values, this will not currently be tracking players standing on it, but that's the next step. But it will be moving up and down slowly using sign, so it will have some natural organic-like motion. It's not very organic. I'm just like, it's really not that organic. Let's try making it more organic by adjusting the amount that we adjust the I by using parentheses 0.1. Let's actually make that 0.25 multiplied by math.random. So that the amount that it moves along the sine wave is actually just different every single half second. So it is moving forward, so it will continue moving in the correct direction, but every half second the speed of it is slowly changing. Could be curious to see how that looks. It could be bad, could be good, we'll see. Yeah, could be bad, could be good, we'll see. Okie dokie. So I think we're ready to go ahead and test that in Horizon. Here we go. We'll let that compile. Looks like it has compiled. Click clear, no bugs. I'm so nervous. Hitting play. All right. They've all moved into position. Jumping into preview mode, we can now see that they don't appear to be moving. So we should adjust our sine wave. Game started. I gotta make sure I don't accidentally go too hard. I don't really see these. Oh, there they are. It's very subtle. Let's kill ourselves before our time gets too high. There's leaderboards and I don't want to be on top of them. Okay, so the problem was the sign was just too small. That's surprising. Let's try sticking with just a straight math.random. And then let's go up here and change this. Oh, you know what? It might not have been, it wasn't, Control Z. It wasn't the amount of speed that was moving that was the problem. It was the amount of distance that was moving. Let's change this to 0.5, Control Save, and see what that looks like. So that's 5 times more animated. And let's go back to Horizon and wait for that to compile. Clear, looks good. Play, jump into preview mode, check it out. Jumping down. All right. There's like a subtlety to it, like just a very, very subtlety of it. And then what we should see is at 15 seconds, it's going to switch seeds, and so everything's going to change rapidly. And I'm going to call this, oh really? That did not change at all. What? Did it? It sure didn't feel like it changed. It definitely is. It's subtle. Okay, let's make it less... More. Let's make it more. More! I enjoyed the amount that it was moving, but I felt like the speed was a little slow. So let's change this to just be straight math.random. This was 25% of math.random, so this is going to be 4 times more now. Control save. Let's go back in here. We'll give that a test. Give that a second to compile. One more. There it goes. Come on. Last one. There we are. And play and preview. All right. So now we should see this a lot more animated. Try not to die. Try not to die. That's a little... Whoa. Okay. Yeah, that's got a lot more animation to it. Enjoying that. Now at 15 seconds, we should see this switch states, but it doesn't seem to be too dramatic. At least not in the easy one. Is it switching? Is it? Let's go up to hard at least, because hard enables the faster moving speed. So we're about to hit another earthquake. Or I'm calling them tremors. But I don't really notice it. That's so interesting. The lava's definitely continuing up. 45 seconds, we should see our next. And 43, 44, 45. Okay, and then... Yeah, it's really peculiar. I don't feel like I'm seeing the seed changes. Maybe seed changes aren't happening as frequently as I thought. Let's go and check the code to see if I'm mistaken. So if we go to Stone Pillar Func, right here when we call set random speed, we can do a console.log. We could also just read the code in the game manager function where we call game state loop. Ah, we were not updating the seed. Interesting. Setting the random seed was only happening in Nightmare and Infernal Lava? That's weird. I thought we would have done that all the times. Let's do it all the times now. All the times. All of the times. And we'll move that to right here because that's going to be the highlight of these state changes or the game state loops. We're going to remove random seed here and control save. Let's see if that adds a lot more excitement as this game changes. Interesting. So, oh, you know why we didn't need to do that, except for in those cases, was because the way that this was being changed, the seed wasn't what was changing. Oh, okay. This is good. This is good. Calling set random seed is what we need to do. The reason the difficulty, that's not what difficulty does. I forgot what difficulty did. So if I go into Stone Pillar function, we can see set the Perlin divisor is what's actually taking the game state. And so this did have an effect on the change, but I don't think it's being used anymore. So if we check set Perlin divisor, what is that actually doing inside of our function today? So Stone Pillar entity, when we have an updated seed, and there was no updated seed, so that's why we didn't know to change it. That's what it was. That's right. So if we go to move to next position, we said if current seed doesn't equal, then we updated this. So the next divisor was never changed, which is what was changing. Okay, breathe. Let me better explain. When you change the divisor, it basically changes the seed because you're dividing by such a different value that it feels like a completely different set of Perlin noise. So in my mind, it's always been changing the seed, but it actually never was changing the seed. It just felt like it because of the way that the divisor worked. But now that it's packed into this, we do need to update the seed every single time, which we are now doing. Cool. That should now function correctly. Let's go check it out. That should be a lot more exciting. Okay. And clear, and play, and preview. Here we go. Whee! Okay, 15 seconds until we see this beautiful, ideally insane change. I do like that this feels a lot more predictable. They're not like, oh, what are you guys doing there? Did I catch you? Nope. Oh, I haven't tried. Oh yeah, see that? The whole thing just changed. That's fantastic. And so now, with this coming on 30 seconds, I can try this. If I drop this, press X to drop, it should freeze it in place while all the others are moving. And then after it's frozen, it then tries to catch back up to where it's supposed to go. Cool, and then we're 3 seconds out from the next state change. And hard, oh no, I missed. But yeah, and then hard is trying to kill you, right? So, nice. Okay, I like this a lot better. It doesn't feel too far off from where it was before. I almost think that the subtle, it's not as subtle as I'd like. So we were using multiply by 0.5. I want to try multiplying by 0.35 and see if that creates a little bit more subtlety in the up and down motion. And maybe even going to like 0.2 because we did change the speed of the sine wave to be a lot faster, which is part of the reason it's moving so much more. So let's go ahead and let's test it out. Clear, play, jump into preview mode. And so if you watch the lava, all you're watching is the sine waves right now. I want to update my to-do list over. Oh, I can't do that on. I can't use my other screen. So that's what we're watching right now is the sine waves. Now when we jump in, we should be seeing that it's a lot more subtle, which doesn't feel like it's going to kill you when you're running around. Like the little ones close to the lava, you kind of want to stay away from. But it does give it a nice like organic feeling. It doesn't necessarily feel like it's trying to kill you yet. We're about to, ooh, I forgot about the state changes. It then tried to kill me. But nice, yes, very nice. Now we're gonna have another state change here in 3, 2, 1, and are we going up? We're going this way, cool. And so then I wanted to look at the snowballs to see if I couldn't try to survive longer. Here we go, big state change coming in right now. Oop, there we go, survived, very nice. Okay, that one wouldn't have killed me, but I would have jumped off of it, maybe in the wrong direction. Okay, so far so good. We're about to hit in 5 seconds, hit a very hard difficulty. Needing somewhere to go. Oh no, still alive. Oh, not for long. That was fun. Cool. Yeah, that's pretty neat. Now the next thing to do is to make it so that the player sinks the tile. That's the next thing to do. So, let me mark off my to-do list some of the stuff we finished. We have made it so that it's organic and bubbly. We made it so that, well, I think that's the only thing it does. That was the only thing on the to-do list done. Okay, okay. But everything else is going to be relatively easy. Don't move unless players are on. That's what we're doing next. Only move down. Okay. Yes. So, every half second, we need to find out if there's a player on us. And if there is, we want to reduce our down by. And so let's start by just moving down easily. We know that this isn't decreasing the position, but it's actually decreasing the scale. And so what we're just going to do right here at the beginning of our current time is say down by minus equals, or no, plus equals, because we're subtracting it, so plus equals. And then we want to take the number of players, which we'll type in 1 for now. And we want to take the number of players and we want to multiply this by something that makes it so it doesn't decrease too much. So let's say that the maximum, if all players in the world are standing on a tile, is it's going to decrease. So we're thinking the scale is about 4 by default. It shrinks down to 0.01 as the lowest. And then if we subtract 0.25 for minus 0.25, so actually 0.25, that'll be good. And then we take the number of players and we divide it by the number of players who are active, which we can do, but we can get by saying player data map. Ooh, that's a problem. Ooh, that's a big problem. No, I guess it's not that big of a problem. We need to know how many players are playing, which I believe is in the game manager. If we go game manager data dot active player count, that tells us how many players are actually down on the lava. So as more and more players jump in, the lava is affected less. So if there's only one player playing, it's 100%. If there are 2 players playing, it's half, and then so on and so forth. And so now we need to know how many players are on top of us. So we're going to say constant players on us equals 1. We're going to need to fix this in a little bit, but we're just using this to get the math correct. So we'll type players on us. Okay. So now that we've calculated this, the math is now good and correct. Down by is going to keep going up until it's fully sunk and it's killed all the players who are standing on it, in which case this will reset when the next seed comes through. Then the next question was, how do we calculate players on us in such a way that it is efficient for all other stones? And that's the problem, because every stone is trying to run the same script. So we could create a special function to calculate this, but I don't think there is a... Oh, maybe there is. There could be a way to do this. Okay, there is a way to do this. What we need to do is go to our stone pillar data, and in stone pillar data, we have random seed, we have divisor, we have max scale speed. What we don't have is all of the entities. And so what we're going to do is create a entity array, but we can actually make this a map. Let's make this a map. Okay, it's a map. That could work. That could work. And so this map is going to be called I'm like thinking of some crazy things I can do and trying to figure out how crazy I want to make this. How much time do I have to? I've only got half an hour to my next class. Okay, we gotta go fast. Think. Easiest way to do this is to store the origin position and use the origin position as the key. So we're gonna say origin position player count map. That is a nasty thing. And so what we're going to do is origin position player count map is going to be equal to a new map where we take a vector 3, and that's the key. The vector 3 is the key, and we're going to map that to a number, which is the number of players standing on that position. And control save. So then, one thing you have to know about TypeScript if you have never used TypeScript and you're coming from code blocks is that when we define start position right here, start position could be a key. I try to think of these as like drawers, and so if there's a drawer, you're referencing that specific drawer. It's not the data that's in the drawer, so you could create another vector that would be like 0, 0, 0. That does not equal the first vector that was 0, 0, 0, because they're separate drawers, basically. And so by utilizing this as the key, we have to use our specific start position that we create right here over and over and over again to access this data, but that totally works. And we call that start position, not origin position. So let's rename this as start position player count map. Control save just to match the naming convention. And then stone pillar function is going to need a special function that's going to run regularly. I guess we can actually put this in game manager, right? That seems to make sense, because game manager has something that's looping. So we go to game manager function, we have our regular loop, right? Get active player count loop. And we only really need to work via the active players. Yeah. So get active player count could totally be used, but I don't want it to be so the same. Let's just copy this and make a function of similar name, and we'll paste it right below. And this is going to be called update update pillar active player count, which will not return a number. And we can delete that. And then we can go and say, after getting active player count, we can then update pillar active player count. And then control save. And updating pillar's active player count will happen, I think this runs like 10 times per second. Let's go check. So if we go to loop, go to game manager entity, we can see that loop is called, only once per second. Slower than I would have thought. I think that's okay though, because of the motion being so organic. I think that's totally okay. So once per second, it's gonna update this count, which is more efficient, right? Okay, so update pillar active count goes and says we don't need an active player count. What we need to do is go through each player data, and if the player is playing and is not AFK, I kind of want to say and. They don't, if they're AFK, they could sync the thing. Okay. Yeah, I guess if they're AFK, they won't count, but then they could stay alive. That's problematic. Okay, they will sync it if they're AFK. Scary, but don't leave coins on the thing if you can't help it. Okay, so now, if the player is playing, we then want to go, and at the very beginning of this, we need to say stone pillar data dot start position player count map dot for each parentheses this is the value, we'll call this the count, and then this is the key, and then arrow function, curly braces, semicolons because I like them, enter, and then we say stone pillar data dot start position player count map dot set. I don't know if you can do this inside of a for each. If we can't, we'll have to switch it to a for loop. We'll see in a second. And then dot set the key to be 0. So we basically start by resetting every value inside the map to 0, and then we go through each player and we have to determine where they are. And yeah, oh, this is way better than what we were going to do before, right? Because I don't know if this is better than what we were going to do before, but it'll work. So we're going to say if parentheses, and then we say player data dot current position. And we need to do this inside of another for each loop. So we say, we'll copy and paste this, Control C, Control V, delete. Ooh, actually, we could utilize that at the end. So move this up and say if player data dot current position, we're going to do some math in there. And then if that's the case, we're going to do some math right there. And so let's start by finishing this. So we have the key, which is in this case going to be called the position. And so current position, distance, but we don't want to calculate the distance along the the y-axis. So we want to remove the y-axis. So what we do is we say current position dot subtract parentheses the position. Now that's going to create a distance vector from those two positions to each position. And then we want to dot multiply using component multiplication by new vec3 of 1, 0, 1. And so that's going to clear out the y value. And then, this is a long equation. And then parentheses around that. And then dot magnitude is going to get the distance of that vector, which is the distance not including the y value. And if that is less than, and we know our tiles are pretty big, but less than 1.5, that should mean they're standing on that tile. And if they're standing on that tile, we're then going to set the key. We might need to check the edges of the tile. Maybe we'll set this to 2.5. So if you're standing on the edge of two tiles, it decreases more than 1. That's kind of a cool idea. Start position player count map dot set key to be start position our stone pillar data dot start position player count map dot get parentheses the position, and then that position, if it's undefined, we'll set to 0, which it shouldn't be, and then because obviously we're inside of it, and then we're going to add 1, so +1. Let's put this inside of parentheses so it's very clear what's going on there. I'll close that so it's easier to read, and then change this to position. So just to quickly recap, we go into the map and we're setting for the current position. The current value of that map is gotten. If for some reason that position is not in the map, we set it to 0. And then we add 1 to whatever that current value is because we just cleared them all up here. So then this will return how many players are standing on each pillar. And now that we have a way to update that once per second, we can now go into our stone pillar entity and utilize that right, where were we? Right here. So this was how many players are on us, and this is stone pillar data dot start position player count map dot get parentheses, and then we pass in our start position, and then we type question mark 0, and then what we need to do on world start is set this. So we'll go Control C, go up to start, and make sure to set us into the map on start if we are not static, right? So this only happens if we're not static. So then we say, this needs to actually happen in pre-start really, because it's kind of early stuff. We'll do that right after connecting, Shift-Alt-F. And now rather than set get, we're going to use set, and we're going to set, oh, but we haven't gotten the start position yet. Okay, we'll move it right below the setting of the start position. Right there, semicolon, enter. And then we're going to set the value to 0 by default, comma 0, Control save. Okay, so our map has been set up on world start. We're now using it to calculate how many players there are. Whew. Okay, back over here, and I've only got a few minutes before I really do need to go get ready for my class I'm about to teach. And then I'll be back in a few hours on the main video tutorials channel showing custom UI. A little more specifically, I'm going to plan to try and do a little bit of, oh shit. What did I do wrong? That was very wrong. How did that happen? Something very simple must be wrong here. Start position equals this dot nt position dot get. We utilize the start position as our key. We set it to 0 in the player count map. We then down here set down by to be plus equal to players on us divided by this multiplied by 0.25. This should return 0, 0 over 0 is, you can't divide by 0. Can't divide by 0. Parentheses, and then do math dot whichever is bigger, so math dot max, and then type 1 comma. There we go. So starts as default of 1, and then it'll increase as players come in. Oops. Did I do that? Clear, and play. There we go. That seems a lot better. Jump into preview mode, make sure they're not syncing by default, just double check. They look good, jumping in. Now as I stand on this, it should sync. Oh yeah, that's syncing. That is also syncing. It does have a 1 second delay. You won 7 seconds. But so we definitely need to update that faster, for sure. Absolutely needs to be updated faster. But not bad. Definitely enjoying this. So what we do know is that wherever we're updating the player position, oh, we just changed modes. I feel like it should go faster than that though. Like, that's not too bad. Maybe based on the difficulty? Based on the difficulty. Interesting idea. So the difficulty is really coming through in the stone pillar function. So in stone pillar function, we set the difficulty here, and we have this divisor of 5. And then we set it to 2, then 1, then 0, 1, and then 0.01. So you could imagine that in the beginning it doesn't take much of effect, and it becomes more of an effect. So if we reverse these, like say 5 minus 5 is 0, so it has no effect, then 5 minus 2 is 3, so it has more effect, then 5 minus 1 is more of an effect, then 0.01, and then it just gets closer to 0. Or closer to 5. That could work. So that's using the stonepillardata.divisor. We also need to update, let me write this down before I forget. So update pillar count on position updates, player position updates. And then what we're working on right now is this. This should be real quick. Okay, so we go to this dot down by, we were multiplying it by 0.25. Let's do this another way. Just going to try to calculate this / and a comment. So we need to get it to 0.25, which is going to start as 5 though. And so we take 5 and we subtract from 5 with, let's actually start with 6. So 6 minus, let's start with 10. 10 minus, and then we're going to get the divisor, which is stone pillar, don't make me type this out, stone pillar underscore data dot divisor. Okay, I typed it out. So we take that stone pillar data dot divisor, subtracting that, that will start at 5, and then as the difficulty gets higher and higher, it increases it to the point where it's twice as fast if we start with 10. If we start with 7, it gets to the point where it is like, what is that? Quite a bit faster. 3 times faster? Quite a bit faster. So we'll do 7. I think 7's the way to go. Now to get this to turn into a number like 0.5, we need to do some more math to this. So parentheses. So we started with 0.25, but that wasn't syncing fast enough. And so I'm actually thinking 7 minus stone pillar data dot divisor. Let's see. The number will start with 2. So on easy, it's 2. 2 divided by 4 would be slow, which would make sense. And then as this gets bigger and bigger, the highest value it would be is 7, which would be on like Nightmare. And on Nightmare, at 7, holy shit. That's a little too fast. Okay, so we'll need to shrink this down a little bit. So if we take some parentheses around this, and then multiply the values by 0.5, that reduces it to be a range of, ooh, we could actually do that to the divisor before the subtraction. That makes a lot more sense. So maximize, or excuse me, remove the parentheses, and then put a parentheses here, remove a parentheses here. So we take 7, and then we take the divisor, which starts at 5. Now it starts at 2.5, and then that 2.5 will drop from 5 to 3, which 3 multiplied by 0.5 is 1.5. So from 2.5 to 1.5, okay? So starting at 5 minus 2.5, let's start with 4. 4 minus 2.5 is 1.5. 1.5 divided by 4 is about just a little over 2.5. I think that's closer to 0.3. And then you go to, or sorry, 2.5, yeah, and then 1.5 subtracts, which brings it to 2.5. 2.5 increases it slowly. And then when it gets to its maximum, you have 0. This becomes 0. So you get 4 divided by 4, which is 1. Okay, I like this. I think this number is the way to go. Boy, is it complicated, but it should do the trick. Backspace, parentheses, Control V. Looks like everything looks good there. So we got 4 minus this cut in half divided by 4 should result in a nice down by. Now the problem we still have to face is that the position tracking wasn't updating this. And so what we're going to do is in here, we need to find out how often is the position tracking loop being called, because I think it's twice per second. But where is this being called from? Is that on the Is that on the player manager? Player data entity? Player data entity is calling position tracking loop 3 times per second. I like that a lot. I like that a lot. Let's go to our game manager function. And under game manager function, we can take this update pillar active player count, Control X. There was no reason that this had to be inside of this loop, so we can then move that to our position tracking loop, which makes sense that it would be in the position tracking script. Control V, update pillar active player count, and then we just need to call that after we update all the player positions. So then we'll call update pillar active player count, semicolon. Now we need to import some stuff, so backspace the A, click enter, import vector 3, control save, and we are now done. Now this vector being used over and over again, we should just create one and use it over and over again, Control X, and then go up here, create a new constant called no y vec equals new vec. Okay. And then down here we can type in no y vec, control save. There we go. Okie dokie. So that will update the player position, so we can mark that as done. Let's check all the things that need to be done. Sync on player standing, that is already done. Track positions and remove from list once their tiles is covered. We didn't do that exactly, but it's still pretty good. Don't move unless players are on. We're doing that. Number of players decrease the effect of stepping on a stone. Increase the effect, yes. Only move down. We are doing that, correct. Set when round starts. Set when round starts. I think that is done. That was just a note that we'd already taken care of. Okay. Heading back into test. Play, clear, preview. All right, and then time to run to work. All right, so we're standing on this. It syncs a little bit faster. It should get more and more faster. So getting up on these tall ones is kind of fun, but we only have 4 more seconds to survive. 3, 2, 1. This is called friendly, so that felt pretty good. Now in easy, things get harder. Oh no, I forgot to find a safe spot. Okay, yeah, this definitely has amplified the fun. So if you weren't with us at the very beginning of this, we were talking about how the problem was by just doing random purlin noise, you didn't have an effect on the world, and not having an effect reduces the fun. So now that we have an effect, the fun has definitely been increased. All right, yeah, we are shrinking this. They're falling way faster. When you have more players in here, it will take a lot more players to... I almost made it to medium. Wow, that was actually way harder than I thought it was going to be. But when you have more players, the falling speed will be a lot less, but more tiles will be falling. So I'm curious to try it out. We'll have to give it a shot maybe later today. Okay, we're in easy now. That's falling because I'm standing on it. That's falling. That's not safe. Eek, eek. And I just remembered that if you stand on the edge, it decreases 2 at the same time. Oh boy. So like all 3 of those. Oh no, oh no. I can't get past 30 few seconds. Wow. Oh my gosh, has that gotten more difficult? I might have to reset the leaderboards actually. Like that is substantially more difficult than it was before. I don't think you can get to 100 seconds anymore. We had one person who'd done it up here. Sorry, Jeffrey, if I have to delete this, I might have to. But I'm not sure, because if you have a lot of players, it won't decrease as fast. It will decrease pretty fast on the higher levels, but... Oh, but then the players dying increases the speed at which they fall. What an unintended consequence. So you want to keep everyone alive for as much as possible so that they don't fall as fast on you? Oh, wow. What an unintended consequence. That is so interesting. I do want to try one more time, trying to get a little bit further. I do think the distance might be a little too much on the edges. I don't know. And I feel like it's falling just a little too fast. So let's change these values up just a little bit. I want to make 100 seconds actually more possible, not impossible, but possible. So let's go to, where was that? Instead of dividing by 4, let's divide by 6, which should make it a smaller number, which means it'll go up less. And then active player count is what we were using. Let's set the default to 3. So it will always max at 3, even if there's no other players. So that way you're never being, yeah, that'll make a lot more sense. And then the other problem was, so that decreases the amount going down. That decreases how it works with singular players, so single players. Because a single player at this point was being hit with 3 times if they had 3 players. So that kind of balances that a little bit. And then there was something else I wanted to change, but I think it's okay. Control save. Like that should do a lot better. Might not even be clear that it's falling at first. Oh, wait. No, that's right. It's right. Clear, play, jump into preview mode. Okay, jumping in. Oh, it was the distance that I wanted to change so that when you're on the edge, like, I think I'm affecting that other one over there. Right? Yeah, even at this distance. So I really want to change that to be more like 2 rather than 2.5. I think that'll be good. The amount these are going down is definitely less, but now that we're in easy, it should be more. Definitely feels like it's going down more, but we're still in easy, right? Like this isn't supposed to be hard yet. So I'm pretty happy here. And standing right here in the center, I'm lowering all, oh, medium. Okay, we're on medium. Okay, this is further than we've gotten in the past. I need to make a crazy jump. Oh, oh, it was too close to the lava, got burned. Okay. Let's go, let's go. I was getting to 60 seconds pretty easily before this, so I do want to see myself hit 60. Let's check the time. Time's 11:50. Hi, Three-Eyed Tiger. Thanks for joining. I'm teaching a class in 10 minutes, so I gotta actually run very soon, but thank you so much for stopping by. I've been updating this world to make it more fun because it was lacking in fun. The users didn't have enough effect on the game, but now, as you'll see, when I stand on a tile, it starts sinking. And so you can try to like sink tiles and kill players off. And so when you're competing, it should be a lot more fun. 3 seconds till the next switch, and here we go. Come on, get me somewhere. Safe. Okay, we're safe. We're in hard. This is further than we've been in a while. Gotta make it to... And they're sinking faster because the higher levels, they sink faster, so that's good too. Wait. Oh no! And we're dead. Nightmare killed us. Cool. I like it. Good. Made it to 60 seconds. Feeling better about that already. Okay, stopping the world there. I think that's where I'm going to end the live stream, guys. But thank you so much for joining in this little Lakes is Live. I'm going to be live doing some more. Got a lot of lava stuff tonight, working on custom UIs. So you'll see that in about 3 or 4 hours on the video main channel. I should look up the actual time that it is. 1, 2, 3 hours from now on the video tutorials channel. All right, guys, I will see you there. Until next time, bye. Bye.